Hello friends, today we are going to discuss about annealing, normalizing and hardening process. Annealing process. It is the process of heating the metal to a suitable temperature and slow cooling inside the furnace. That is, the cooling is done inside the furnace at, at a very slow rate. As a result of slow cooling, the metal occurs an equilibrium structure which occurs the following properties. To relieve internal stresses, reduce hardness and improve ductility. To refine the grain structure, to produce a definite uniform ductile close grain structure. Here you can observe that the difference between annealing process and normalizing process. In annealing process, the cemented that is formed is little bit far away, whereas in normalizing process, the cemented that is formed is at very congested positions. That is, it's very close to each other. The major applications of annealing process is casting and forging and pressworks. Types of annealing. Full annealing, especially for hypoelectric steels. The steels contain less than 0.70% carbon and heated between 723 to 910 degrees. This is done to obtain austenitic structure and the temperature is maintained for a period of time. Cooling is done in furnace by decreasing the temperature 10 degrees 30 degrees per hour. The specimen is removed from the furnace and air cooled to room temperature. Structure of perlite is obtained which has a uniform medium coarse grain size which is soft ductile in nature. For hyperelectric steels, that is greater than 0.70% carbon, the points are similar to that of hypoelectric steels and the heat treatment is only done at 723 to 1138 degrees centigrade. Structure will be coarse perlite in nature. Objectives of full annealing: softening the metal, refining crystalline structure, reduces hardness, relieve internal stress, improves machinability, and improves ductility. Process annealing, specially applicable for low carbon steel. It is a heat treatment process used to soften and increase the ductility. The metal is heated between 650 to 750 degrees centigrade, held for a period of time to achieve softening. Later, they are cooled. The process leads to recrystallization, leads to improving ductility, softness, free from internal stress. The above heat treatment results in hardness reduction and increase in percentage of elongation. That is, the tensile strength of the metal increases as the process annealing is done on the metal. The sheets and wires manufacturing are the common applications that is performed on the metal in process annealing. Stress relief annealing. Stress relief annealing is usually applicable for alloy steels, that is, employed to estimate the internal residual stress induced by previously strain hardening metal cold working process. Casting, machine, cold working, welding, forging, rolling, that is, during these processes, the internal stress in the metal increases. This leads to breakage of the metal. That is, to avoid this, the internal stresses of the metal are to be removed. The internal stresses of the metal can be removed by using plastic deformation process, non-uniform cooling of the metal, heating and cooling of alloys made with two different metals having different densities. Effects of internal residual stresses, that is, the main effects that are caused due to internal residual stresses are: if the stresses are not removed, distortion or warpage of the metal occurs. That is, warpage is nothing but the breakage of the metal. Operation that is performed during stress relief annealing process. The alloy steels are heated to 650 to 750 degrees centigrade, held for a period of time and cooled slowly. This type of treatment is called as recovery, which is the phenomena that removes internal residual stress with little change in mechanical properties and no drastic change in microstructure. Spheroidal annealing, especially for high carbon steels and tool steels. These steels are too hard, difficult to machine. The heat treatment is done between 750 to 800 degrees centigrade and holding the specimen at a same temperature for several hours, that is about 2 to 5 hours, and cooling it inside the furnace. This causes a spheroidal formation, which is cemented structure which is hard in nature with soft grains. Objectives of spheroidal annealing: to soften the hardened metal, to improve ductility, machinability, formability, to maintain medium hardness, strength, and wear resistance. Now let's go to normalizing process. It is mainly applicable for low, medium carbon steels and alloy steels. It is the process of heating the metal and cooling the metal in air. Objectives of normalizing process are to refine the grain structure, increase the strength of the metal, non-uniform structure when compared to annealing process, relieve internal stress, improve machinability and ductility. Operation that is performed during normalizing process are: the steel is heated between 750 to 950 degrees centigrade. It is held at a temperature for a short time, that is 15 to 30 degrees, allowed to cool in air. Due to faster rate of cooling, normalized steel possesses fine grained structure than that of annealing process. That is, the metal obtained during normalizing process is much harder than that of annealing process. Now let's know the difference between annealing process and normalizing process. The grain size of the metal that is obtained during annealing process is coarse grain, whereas fine grain is obtained during normalizing process. The annealing process is more expensive than that of normalizing process. It is more expensive due to cost of furnace and temperature sensors. In annealing process, cooling is done inside the furnace, whereas in normalizing process, air quenching is done. That is, slow rate of cooling is done. More time consumption during annealing process and less time consuming during normalizing process. Process is done below 900 degrees, process is done above 900 degrees. To relieve internal stress and to soften the metal and improve the ductility. In normalizing process, mechanical properties of metal like strength and toughness improves the mechanical properties like toughness and strength in normalizing process. The grain size in annealing process is more and uniform, whereas the grain size distribution is less and non-uniform in normalizing process. Less hardness is obtained and more hardness is obtained during normalizing process. Hardening process. It is a heat treatment process which increases the hardness by quenching. Steel is rapidly cooled from austenized temperature. After hardening process, the microstructure produced during martensite will be martensite in nature. That is, steel is heated between 725 to 900. This is the temperature range of the heating process. Whereas during soaking process, that is, the heated metal is held at a temperature for a period of time to allow complete austenite formation. Whereas in the cooling process, steel is allowed to cool in water tub or oil bath to room temperature. Purpose of hardening: to improve the hardness, wear resistance, ability to cut other metal, improve strength and toughness. Applications of hardening process are cutting tools, machine tools, where high resistance and wear resistance are important. Factors affecting hardness: carbon content, quenching media, and specimen size. Types of hardening: work or strain hardening, age or precipitation hardening, air hardening, hardening by heating and quenching often. Hardenability Hardenability determines the depth and distribution of hardness in a material induced by quenching from austenite conditions. Hardness are measured by Brunel's, Rockwell's, and Vickers hardness tests. Factors affecting hardenability: steel consumption, austenite grain size, steel structure before quenching, quenching medium, and method of quenching. Jominey and quench method is also an hardenability test that is performed worldwide. It is a universally adopted test, easy to perform, gives information to the designer and the manufacturer about the metal. The specimen for preparation, the standard specimen that is used is: dimensions are standard. The material of the dimensions used in this jominey and quench method is standard. That is, the cylindrical shape is about 25 mm diameter and 100 mm length, machined at one end and fixed to collar. Specimen is heated to austenitic temperature and transferred to jominey and apparatus. Distance between specimen and pipe is about 1.5 inch. Water is allowed to flow and bottom end through 12.5 mm dia pipe and for 20 minutes. Water is cooled at room temperature. Bottom end. quenching top and normalize. That is, the bottom end is applied to condition like annealing process, and the top end is performed to normalizing process. That is, two different hardness can be observed in the same specimen. Specimen is measured by Rockwell hardness for every 10 mm or 20 mm. The greater hardness will be quenched and where martensite properties are obtained, and lower hardness will be on air quenched area. This is the main application where we can see both normalizing and annealing process performed on the same metal. Thank you for watching this video.